Welcome. In this video, we'll discuss the rhythm behind training neural networks. The concepts like epoch, batches, or iterations. Let's talk about epoch, batch, and iterations. So, first, what is a sample? A sample is a single row of the training dataset. So, if you in your training dataset you have, let's say, 10,000 rows, or for image dataset, let's say you have 10,000 images, or maybe if you have 10,000 documents. So that means you have 10,000 sample in your dataset. So what is epoch? Epoch is, let's say if you have 10,000 data samples for training, then going through all the 10,000 samples means one epoch. That means going through all the data samples means one epoch. And what does it mean? One forward pass, one backward pass of the data samples. Now, often one epoch is not enough for our training. So, we need to feed the same data again and again to improve the training weights. So, going through the data samples one time is not enough. We need to feed the same data again and again. And usually, data is shuffled at the start of each epoch. So why? Because to prevent the model from learning the order of the training data. So otherwise the model will try to learn the order of the data, which is not required, right? And model will tend to overfit. So and this, if we shuffle, it improves the convergence and reduce the risk of overfitting. Now, what is batch? So, in our previous video, we talked about different types of gradient descent, right? Batch gradient descent, stochastic gradient descent, mini batch gradient descent. So, these are based on different batches, batch sizes. We divide the whole data set in multiple batches. So, for batch gradient descent, whole data set is one batch. So, if you have 10,000 data samples, the whole data set is one batch. For stochastic gradient descent, each data sample is one batch. For mini batch gradient descent, we decide the number of data samples in a batch. So let's say two data samples in one batch, right? So that is possible. So these are, let's say, the training samples, S1, S2 till Sn, n samples we have, and this is the iteration where we are computing the gradients. So all the data samples are used in the iteration to compute the gradients and update the weights. So we update the weights in the gradient descent like this, right? Wt minus alpha, gradient of this error with respect to the weight parameters. So that's how we update the weight parameters, right? And this update, all the training samples are used to compute the gradients and updating the weights. For stochastic gradient descent, each sample is used in one iteration to compute gradients and update weight, right? So S1 computing gradients, update weight. We took consider S2, we compute gradients, update weight, and so on. For mini batch gradient descent, let's say we consider the batch sizes 2 here, right? So n samples, 2 samples in one batch. S1, S2 in one batch, in one iteration, we are computing gradients, updating weight. And S3, S4 in separate iteration, separate batch, computing gradients, update weight, and so on. Now, iterations. So, you know about the iterations, right? So, let's see a few more things. So, for each batch, there will be one iterations, right? So, hence the number of iterations means number of batches needed to cover one epoch. So, let's say if you have this n data samples, right? And your batch size is m. So, let's say your batch size is 3 here. So, this is batch size. So, how many batches you will have? We'll have n by m batches. That means n by m iterations. So we need n by m iterations per epoch. So going through the whole data set means one epoch, and we have n by m iterations per epoch. So if we have L epochs, we are going over the data set L times, so then mean total iteration is L times n by m. This many iterations will have. Now this is how the weight updates looks like. Let's say this is epoch 1, this is epoch 2. We can have as many epochs we want based on our data set and training. So this is in epoch 1, we have 1, 2 till n by m, this many batches. And these are the weight updates. And after first iteration, weight update is W1. We get this weight. After second iteration, we got W2. This is the weight after second iteration. And after n by m, we get Wn by m. When the epoch 2 starts, so this batches, the whole data set is shuffled, right? So we get different batches. But we start with the weight updates from the last point, where in the last epoch we get n by m plus 1. Thus again we update the epoch. Now one of the benefit of this shuffling is, in case of mini batch gradient descent, if you shuffle the data, every time you are getting a different mini batches, right? So that improves our training, and we have less chance of overfitting.